Hi everyone, welcome back to my channel. I am Shayande and in this video we will be talking about the differences between classical machine learning and quantum machine learning. Also, we will be discussing more on how classical machine learning and quantum machine learning works. And then we will discuss about the 4 pillars of data. So, without wasting any more time, let's get started.
So let me just start today's discussions. So today we'll be looking forward the basic differences between classical machine learning and quantum machine learning. Then we'll be looking for the learning process for the classical machine learning and also the quantum machine learning. And then we'll see about the 4 pillars of data, like we have classical system and quantum system. So there will be some data mismatch, right? So how do we actually use classical data into quantum? We'll be seeing that into this section. So let's start with the basic differences between classical machine learning and quantum machine learning. So before going to the discussion about classical machine learning, let us just revise how classical computer works, like what is the base of classical computer. So anyone can say that it is a classical bit. Now what is classical bit? Well, it is the fundamental unit of information in classical system, which is by calling bit. That means it has 0 or 1. So basically it is either 0 or 1. So either 0 or 1. Remember the term here or. Okay. For example, if I am tossing a coin, so there will be only 2 options, right? Head or tail. So it can be either head or tail, just like true or false, high or low, or 0 or 1, right? So to process this kind of informations, we have logic gates like AND gate, OR gate, NOT gate. We also have NAND gate, NOR gate, XOR gate, exclusive NOR gate also. So these are the all gates we have. So for example, if I take an example for AND gate, maybe I have A and B here. So the output will be A and B. For example, in OR gate, if I have A and B as input, I'll be having A or B, right? In NOT gate, you can see that it's a 1-bit gate. That means if I pass an information and input A, I'll be getting A bar. Okay. So AND gate, OR gate. So these gates are an example of 2-bit gate. Okay. But NOT gate is basically 1-bit gate. Clear up to this? So next, what is the basic difference in quantum computer? Here the fundamental unit of information is the qubit, that is quantum bit. Here we also have 0 and 1. So please listen carefully. Here I am saying and 1. In classical I was saying or 1, like 0 or 1, either 0 or 1. It cannot be both in classical. It should be either 0 or 1. But in quantum information processing or quantum computing, we'll be saying 0 and 1 with some probability. So you will be having 0 and 1 at the same time. So let me just take the same example of flipping a coin. Now, if I ask you to observe the position of the coin in the midway or in the mid-air. For example, I am tossing the coin. So it is tossing in the mid-air and it is rotating like this one, just like this one. So it is head and tail at the same time while rotating, right, in the mid-air. But when you observe it, it will be in classical, right? It will be either head or tail. But in the midway or in the mid-air, it is head and tail. I hope you are getting my point. So in the midway or in the mid-air, when the coin is spinning, or in technically when the information is processing, so it is both, right, head and tail. But when you observe the coin in the ground, then it will be either head or tail, right? So to process this kind of information, we'll also have some gates. Here we will be calling poly X gate, poly Y gate, poly Z gate, header and gate, C0 gate, CC0. There are lots of gates are there. So we'll be discussing each and every gate in our upcoming videos. Now let us just focus on the learning process of classical and quantum machine learning. Let us just start with how the classical machine learning works. But before that, let us understand how the traditional programming works. For example, I have a computer like this. So in traditional programming, we are providing data and rules, and the system provides us some output. For example, if I have a data like x equal to 1, 2, 3, 4, 5 like that, and I also have one rules, that is maybe y equal to x square. So what will be the output then? The output will be 1, 4, 9, 16 like that. Okay. So these are basically traditional programming. We are providing data and we are providing the rules to the system, and it is processing the data according to the rules and it is giving us the output. Now what about machine learning or classical machine learning? Now things get interesting here. Maybe we have a system like this. Now we are providing the data and we are also providing the output here, and we are asking this computer to generate the rules between this output and data. Am I clear? So in machine learning, in classical machine learning, we are providing data and the corresponding output, and we are asking these ML models to predict the rules, to predict the rules. For example, if I have the same data, for example x equal to 1, 2, 3, 4, 5 like that. Now I have given x as my data, and let me just provide the output here also. Maybe it is z. Maybe z is the output. 1, 4, 9, 16, 25 like that. So now we are asking this machine learning model or machine learning algorithms to identify the relation between x and z. Maybe the relation or the rules is x square. So these rules needs to be predicted, needs to be identified by the machine learning model. So this is the main task of machine learning. Now let's see the formal working process of a classical machine learning algorithms. So we'll start by using some data set. Either we'll have the data or we'll be creating the data. Data set is mandatory then in the classical machine learning, maybe in supervised or unsupervised. Then we pre-process the dataset, right? We do some processing for the null values, we do something else. So everything comes under the pre-processing part. Now the main part is feature extraction. Maybe you have 100 of features. From that, maybe you have 5 important features. So that you have to extract manually or using some another model or something like that. So this is really important in classical machine learning. And after that, we train the model and then we evaluate the model on the test or validation dataset, and we deploy the model in the server. So this is basically an overall process of how classical machine learning works. When we talk about machine learning, let me just introduce a small part about deep neural network or deep learning. So as you can see here, we have the input layer. Here we have the output layer. So in between, this is all our hidden layers. Okay. So from input, it is going forward like this. Okay. This is called feed forward network. Okay. Now at the output part, the model calculates the error, and based on the error, it recalculates the weights to update the parameter and to learn. So this learning algorithm is called back propagation or back prop, for example. So if you want to learn more about back propagations, I have already made a video on that, and the link will be in the description box below. Please look into that. Now let's talk about the working process of classical machine learning. Here also we'll start by using some dataset. Well, obviously it will be some classical dataset, right? Because we don't have quantum data to store. And after that, here the pre-processing is basically the data encoding. Right now we have lots of data encoding process. Now based on the requirements, we select some data encoding methods. So whatever it is in the pre-processing part for classical, maybe it is the pre-processing for the quantum machine learning, that is data encoding part. This data encoding part leads to the state preparations with BRA0, KET0, something like that. And after that, we have some quantum machine learning algorithm that we train with. And after that, we measure the output and we do some predictions. So this is an overall idea about how quantum machine learning works. For example, if I have this kind of information where we can see that this is my quantum part, where we have the state preparations and we have the quantum circuit. Now here, after the measurement, we have the output, right? From this output, remember, when we observe any state, it becomes classical. So we have the classical output, then we do some calculations here, we update the parameter back into the state preparation module. So we have an hybrid approach here. One is quantum part along with some classical part. So this is an hybrid approach. Well, now let's talk about the 4 pillars of data in classical and quantum machine learning. So we have something like the type of data and type of algorithm or model. Let us just start with the first one, that is CC, that means classical data, classical model. So these are the things that we always do with the machine learning, normal machine learning or classical machine learning. We have the classical data and we have the classical machine learning models or algorithms. We train in the classical system and everything works fine, right? After that, we have classical data with quantum model or in the quantum system. So this is the dream one, that is we are working on. We have the classical data, we encode this into quantum state, then we process the quantum state, and after that with some quantum machine learning models we will be having some output. So this is the part that everyone uses right now. Next we have quantum data and classical model. Maybe we have quantum data and there is a chance of processing this quantum data with some classical models. So that becomes an optimization problem, right? So we have some quantum data that will be processed by the classical models or classical systems. And now comes the biggest dream, that is quantum data processing in the quantum model or, for example, quantum system. So basically you'll be having quantum data. That data can be processed using a quantum computer. Okay, so quantum data and the quantum computer, this is the ultimate one. But due to some hardware limitations, we only have the CC, that is classical to classical. We also have some CQ, that is classical to quantum. Researchers are also trying some part on the quantum data and the classical model, but this QQ, that is quantum data and quantum model, so this part will be in the upcoming future and we are eagerly waiting for that one.
So that's all for this video right now. If you learned something, please subscribe to this channel. And if you have any question, any doubts, any queries, please let me know in the comment section. I'll be happy to answer you. So thanks for watching. See you in the next video. Bye.